Welcome back. We're going to wrap up this section with a conversation about how to find some information about a sector. So, a sector is a portion of a circle. Okay, so I've got here a whole circle. But if I talk about just this portion of my circle, and understand I drew this in standard position. Sectors don't have to be in standard position. They can be anywhere around the circle. This is a sector. It's subtended by an angle theta. The circle has got a radius of r, and we could calculate the arc length of this sector. And the arc length, in other words, the distance we would walk along the perimeter of the circle to get to that point on our circle, is simply be given by S equals r theta. But theta must be in radians. Because this goes right back to our definition of a radian measure. Remember that a radian measure is equal to the arc length divided by the radius. So it makes sense that S equals r theta. Now similarly, we can talk about the area of this sector. And area is equal to 1/2 theta r squared. Okay? So why do we care? Well, because this is how we answer questions like a lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of grass the sprinkler waters? So what we have is something that looks like this. 30-degree angle, a radius of 20 feet. We know that area equals 1/2 r squared theta, but we also know that theta must be in radians. So the first thing we have to do is convert 30 degrees into radians. And now we can calculate our area, which is be 1/2 times 20 squared times pi over 6, which is approximately equal to 104.72 square feet. And you can put that in a calculator to figure that out. Okay, now the other thing that we're going to talk about here is angular versus linear velocity. We're familiar with linear velocity, so we'll start with that. Linear velocity is simply distance divided by time. Okay? Now, we're going to use S because we're talking about linear velocity as we're going around the circle. So my linear velocity is my arc length, the number of arc lengths I travel divided by time, or the arc length that I travel around my circle divided by time. My angular velocity is how many radians I go through at that same time, or how many degrees, because we can do this. We usually do it in radians. We can do it in degrees, but it's really my angular rotation per unit time. So omega equals theta over time. And we could do some algebra and use the arc length definition, and it wouldn't take us very long to figure out that there's a relationship between my angular velocity and my linear velocity, and it is that V equals R omega. Okay, so let's put this into work. Let's suppose that I have a bicycle with 28-inch diameter wheels. And a bike shop tachometer determines that the wheels are rotating at 180 RPM, revolutions per minute. How fast would the bike be going if it were being ridden down the road? Okay, so let's take this apart piece by piece. I've got a circle with a diameter of 28 inches, which means that my radius is 14 inches. Okay. I've got, what am I given? I'm given actually an angular velocity. So revolutions per minute is an angular velocity. Now, it's not the type of angular velocity we are looking for because we really want radians per minute. So we remember that there are 2 pi radians per rotation. And we see that 180 revolutions per minute is 360 pi radians per minute. And this is my angular velocity. Excellent. Because now I know the velocity is equal to r times omega. which means my velocity is 14 inches times 360 pi radians per minute. Now, radians is actually a unitless dimension because it's a length divided by a length. And so my bicycle will be traveling at 5,040 pi inches per minute. Now, our brains don't really think either in terms of 5,040 pi or in terms of inches per minute. We really want to think about this in miles per hour. If we can't have that, then at least feet per hour, but preferably miles per hour. So let's do some work with this. So 5,040 times pi inches per minute. I'm going to multiply that by, first I'm going to get us into hours. So I'm going to multiply by 60 minutes per hour. And now I want to go to feet, to miles. But before I go to miles, I'm going to go to feet. So I've got 1 foot per every 12 inches. And 1 mile per every 5,280 feet. And if I multiply all this through, I end up with just shy of 15 miles per hour. All right, that's it for this section of the text. Please reach out if you have any questions, and I will look forward to talking to you again soon.